the genesis of this talk is the fundamental observation that in the IoT industry, it's been about 10 years since IoT's been pretty hot and heavy. And the end result of that is that the IoT development experience is still kind of marginal. And Zymbit has been with it all the way through. I'm the CTO and the co-founder. And these are the lessons and some of the insights that we got out of it. So I'll start with a quick intro, which is for context, kind of what we did, and then we'll get to the point. So a long time ago, we thought, all right, great, IoT is awesome. Our background is industrial engineering. We're going to go ahead and we're going to fix the most basic security problem. We're going to put together an HSM. This was built for the Raspberry Pi. It worked quite well. Everything was fine. We built it and we thought, we're done. We're going to solve the problem, and that's pretty much all that we got to do. It was inexpensive. It had built-in physical protection, so something's truly designed for the unattended machines. That was all fine and well. Then we said, all right, great. Why not a better one? So we built a better one. We made a better one. Everything was fine. We actually did a hardware wallet in it. That was the time of the fun crypto days, but we used it more for industrial IoT. So that went pretty well. Lots of slots, secret sharding, power monitoring, all this other stuff. Then we started to kind of notice a bit of a problem. So we noticed that most of the customers don't know how to use it or can't really use it because they just don't know any of this. So then we said, all right, well, why not fix that? So then we built a compute module. So we took a Pi CM4, which is on the other side, and we made a fully supervised system out of that. So, all right, well, that's ought to do it. So folks should be able to go there, put the stuff on, and securely load their software and go ahead, and everyone will be happy. All right, so we put a super cap and accelerometer, a pretty high-end product, but we can always make it less high-end product. So we had all that. Well, then we said, well, that doesn't quite work. People are still not building nodes. And we have customers that are saying, can you build us a node? So this is all customer driven. So every time the next customer came along, we have added things. So we build the node. This is the first gen of the node, which happened approximately 3 years ago. That was very highly reviewed. People said, wow, this is the first real physical security, physical root of trust node. No one else has it. Military folks loved it. Drone people like that kind of stuff. So went well, but still, you know, this is one of the most secure computers. This is from gentleman Jeff Geerling, one of the YouTube Pi star reviewers, said, wow, this is great. Yeah, and that too. So really, really tough to use. So we said, all right, we got to fix that too. So we went on and said, all right, well, that's what's going on inside. So we got the hardware security module in there. We have a full supervisor. So this is the thing that goes in there and monitors everything even prior to boot. So we can fix boot errors. We can verify all the artifacts. We can boot the system. We can fully control it. So this is like a old school IPMI server, but done in this size. I can't quite show the size, but it's the size of a Raspberry Pi compute module. All right, fine. You put your Linux on there, and everything should be fine. Well, then people brick them because they arm them and then they brick them. All right, so you need A and B because you need failover, and that's all fine and good. So we put A and B on it. Then we have discovered that these two guys fight. They're territorial penguins, and they try to override each other's boot artifacts and do all sorts of wonderful things that, again, end up in a very secure brick. So it's all right, fine, we'll fix that too. So we gave them their own keys so they can't write to each other's file systems. They can't do anything weird. And we built an isolation thing. They have separate things. Great, sounds good. You have to manage that. So we built a piece of software that manages that. Puts the images up. Now, again, this is all by necessity. None of this is gratuitous feature adding. This is all stuff that you have to have, otherwise things brick. And this is real world deploying secure devices and seeing what happens. What happens from the HSM all the way up to here. All right, so we fixed that. Everything was fine for a short amount of time. Notice that now we have multiple OS keys and we still have the supervisor and all that other stuff still going on. Then the customer said, well, but where do we store shared things? Things are now extremely isolated. All right, so we did the share storage. Again, with the keys, now we have even more keys. The keys and keys and keys. Everything has got its own keys. Then we said, all right, well, this ought to do it for everyone. And people said, no. We also need a safe mode. And that's a legitimate request. So we have that. That also lives on the device. And then a couple of backup copies. I don't know, how far does this go? All right, so this ought to be enough for anyone and everyone out there. This has got to be it. Okay. So is this truly it? Well, then, because this is IoT, and this is Edge, and this is people want to hook up stuff, this is real. This happened. That is an enterprise toaster. And that has to be monitored. So how do you hook that up, and how do you integrate that? That came up. And we decided that the toasters running 64-bit operating systems is not really the best idea. And now keep in mind, of course, if there was 10 billion toasters and we could just do a $10 device and we could monitor them all. But there's a toaster, there's an oven, there's a fridge, and there's all kinds of things. So it's not all the same. All right, so 64-bit toasters was not it. We decided not to go down that route. So we made a small node, which works as a remote I/O. Now, again, this is all in pursuit of very basic customer requests. How do we do high-value IoT for a population of slightly complex devices? We don't like to, but do call it complex edge. And this is absolutely real. So, all right, fine. Did that. You can have one of the nodes. You can have multiple small nodes. You can attach the enterprise toaster to it. And you might as well fix everything else while you're at it. So we built the mesh. Why did we build the mesh? Well, because the more devices you add, you should be adding reliability as opposed to taking it away. Again, this is all in pursuit of some basic tenets of secure IoT. Locking up file systems, locking up keys, isolating operating systems, enabling updates. So this is not a fanciful something for a military contractor. This is for a retail location. This is for a typical smart retail operation. You need all this stuff. All right, so at that point, we kind of stepped back and tried to figure out, well, what is really going on? Why is this so difficult? And why are we 10 years in and we cannot really, it's still tough. So that's where the observation is that all this was an intro to the actual subject of the talk. So this is data from Space Shuttle 124. This is the, I don't have a laser pointer, so the magenta purple curve is the pressure on the top of the rocket. This is pretty significant numbers. This is, it's about 3 cubic yards of water on top of each area. So this is quite a bit. So they figured this out a while ago because the atmospheric density is such that there's a point where the rocket experiences the maximum amount of pressure. And they actually throttled it down. You can see that little white line, that's the actual throttle. And then you have the velocity and the pressure. So I took this chart and did some gratuitous relabeling. And that's what we've learned in a nutshell. That IoT projects are just like launching these things. And in fact, with some more gratuitous labeling, that's really what's going on. And so the pilot is that. The pilot is when your rocket blows up. And so that gave us the appreciation of what it really means to get these secure, actual, real IoT, which we consider to be what IoT should be, really for everyone, not just for rockets or life and safety critical. This should be for everyone. This is really what's going on, and we see it time and time again over 8 years of IoT deployments. Things flame out right about there at the top. I would kindly request the management in the audience to throttle down right about there. The engineers in the audience would appreciate it. This is another way of talking about this, a little bit more formal, which is how we evaluate projects. So we now, every project that comes through to us, we view it through this lens. Where is it? So you can see the prototype is fun and good, but not necessarily the best option in terms of really figuring everything out. But then the pilot is the highest pressure point, and then everything else beyond that goes a bit easier. The problems obviously change. So this is the key thing. So these are the key takeaways. I'm getting up in time. So MaxQ with the pilot is really, more often than not, there are exceptions, of course, but more often than not, that is the make it or break it point. And what does it mean to be successful with a pilot, right? I mean, pilot, doing 5 devices somewhere out there isn't really a pilot. A pilot is answering the key question, does this go forward or does this not? There are business questions, there are technical questions, and any other questions, really, can the organization support this? So you have to hit all these 3 things. You cannot just do 1 or 2. You have to have all of these. You fail on one of these things, and you're in massive trouble, one way or the other. I'm not going to go through all these, but everyone can see here what happens if you miss one of these. So what is it? What are the key things? Pilot units need to be secure and unbreakable. I think that goes without saying, because if they're not secure, they have a problem. If they're breakable, then you cannot update them. Architectural flexibility, because you're heading into the unknown, and I think a lot of people try to plan for the unknown. It's hard to plan for the unknown. So the architecture must be watching your back, essentially. That's the only thing that can watch your back. It's not the money. We have seen companies with unlimited budgets fail at this miserably. Unlimited budgets, practically. So it's not a question of money. It's a question of thinking about it the right way. So this is just going back to, so all this stuff within the context of MaxQ is what saves people's butts. Quite, maybe not quite literally, but that's what it is. All this massive amount of code, hardware, keys, key derivation is all, seems to be, at this point in time, it's required. It's not an option. Yes, there are exceptions. Uniform devices, simple fleets, yes. No command and control, only data gathering with where you can drop packets, yes. Simple security things where there's no intermediaries or you don't need to evaluate data, yes, you can avoid this. But other than that, anything that's got any sort of a complexity or higher value, larger scale, unknown deployment schedules, weird networks, weird networking circumstances, you throw any of a couple of easily available things, and you have a problem. So just a quick observation here. This is from our customers. When is not a good time to consider your options? Turns out it's never a good time to consider your options. There's always a good reason why not to consider your IoT architecture. I suspect I'm seeing a couple of smiles in the audience. People have seen this. This is absolutely real. This is from our in-field experience. That's what goes on. During scale out is like the best. Can you guys add this to our device? We have like 2,000 deployed. Planning is essential. I think it goes without saying. It's just a recap. Yeah, we don't have to suffer. We don't have to suffer with this. This is preventable, it's plannable. And also the last one, software engineers in the audience would understand. Don't optimize your project before you've answered your key questions on it as to what's important. Because it's okay to deploy a pilot with a more capable unit and have it be super successful and then optimize it. The management might grumble. I might grumble, me being management, but it's okay. Because you have succeeded in the most important thing, which is you've gotten a pilot through, you've answered key questions, and everything else is just a matter of time and money. Last one. Again, this is just a thought. How we think about pilots and post-pilots is that this is also missed. I put it in here as an extra observation. This is the bonus slide. Architecture should be such that the more stuff you add, the better it becomes. Doing single uplink radios in enterprise applications with high values writing on them is not that, because your probabilities work against you. So make your probabilities work for you. Make it so that the more things you add, the more reliable updates you have, the better cryptography you have, and so on and so forth. With that, questions, our booth is right there. I've skipped over a ton of technical detail. We have the units and everything else. Thank you.
Alex, thank you. That was really interesting. And now I know what MaxQ is. It's the maximum dynamic pressure of the in the aerospace world, and it's where the rocket blows up if you don't manage it properly. So pressure testing your pilots. Are there any questions? Oh, good, because I have one.
Go ahead.
I thought I saw one of your slides. You said something about you had important characteristics of a pilot that you had concluded from some of this work, and one of them was that it needs to be able to scale.
Yes.
Pilots and scale, to me, don't actually go together. So I'm curious, can you talk about that a little bit? Do you plan to scale the pilot itself?
Well, ideally, so the way we see it is that security architectures are pretty pervasive. And so the less of a disruption you have from one to the other, the better off you are. Because what happens in practice, at least that's what we see it. Oh, pilot is good. All right, when can we deploy? When can we do 5,000 units, 10,000 units? So we just found that generally speaking, what people do in pilots, they try to push it onto onto the scale. Now, there are differences. Of course, there are applications which are super massive where you have more of a gap, and you have companies that do treat this as two separate disciplines. But the other part of this answer is that the complexities of the pilot are very similar to the complexities of the scale when it comes to the security perspective. And so you might as well, and in fact, pilot devices, we put more features on our pilot devices. We have separate versions of the units, pilot versus production. The pilot units have more stuff on them because you don't know what you're going to need, and then you pare it down. So we find that the easier, the smoother, the better.
Well, then, thank you. How about a round of applause for our speaker?